All right, so let's talk about the seasons for a little bit. We know them as the four seasons: spring, summer, autumn, and winter, right? So on the left side here, this is Earth in its orbit around the sun. Very generally, we have where it started in spring. On the left side over here will be summer, down here will be autumn, and over here will be winter, at least for the northern hemisphere, right? Um, Couple things to note about this diagram. As the Earth orbits, notice that the axis will keep the same orientation, right? But every day, as Earth orbits, that stays the same, but Earth rotates on that axis, okay? On the upper right is a more zoomed in view of the Earth, and that point, that tiny sun, is the point on the Earth for which the sun is directly overhead. So anyone standing on the equator as Earth orbits will get the sun straight overhead at their zenith, in other words, at least once a day, okay, as Earth rotates on this axis. That point, by the way, is known as the subsolar point. Okay, it's below the sun or under the sun. All right, that red line there, that's the latitude of Fresno. Fresno has a latitude of, I think it's 36.5, but that's the closest I could scroll to. On the bottom right, this shows us the angle of the incoming sunlight. So from Fresno, on March 21st, when the sun is directly over the equator, the sun appears to be, well, that high in the sky, coming from up here, right? Shining at that angle, whatever it is, okay? So let's keep an eye on the location of this subsolar point and the angle of the incoming sun rays as we go around the orbit. Okay, let's watch. So going from March into April, look what that position is doing. It's moving from the equator. Now every day, day after day, it's moving up in a northern direction towards that other line, that other latitude right there, called the Tropic of Cancer, right? This line right here. And so on June 21st, the June solstice, the sun is directly above an observer's head at that latitude. On the left, the northern hemisphere is pointing towards the sun, the southern hemisphere is pointing away. So on this date, it's the first day of summer, it's the longest day of the entire year, at least for observers in the northern hemisphere. The sun's angle appears to be higher in the sky in the northern hemisphere and lower in the sky in the southern hemisphere. And we can see that on the bottom right here. Again, this is from our perspective in Fresno. The sun appears to be pretty high in the sky. Okay? That position there is getting close to that red line, but it will never reach that red line because the sun in Fresno will never be above our heads. Okay? So because of the sun's angle, this will give us the longest day of the year and thus the hottest day of the year. Let's take a quick look at this sunlight spread, right? It's a pretty small region that the sun's light is shining on, right? All of the sun's light is, well, shining in, say, one box, okay? We'll look back at that in 6 months and see how that shape has changed, okay? So now, it's the summertime for observers in the northern hemisphere and wintertime for observers in the southern hemisphere. Let's watch what happens to the position of the sun as we keep moving along. Into July, into August now, that position is going back down. It's turned around and gone south now and is approaching the equator again. So now on the September equinox, it's back above the equator. Okay? Now observers everywhere on Earth get the same amount of sunlight because it's shining equally in the north and the south. The sun's angle, again, has gone a little bit, well, I don't want to say steeper, but it's decreased a little bit. It's not as high in the sky as what it was 3 months ago in June. If we continue on, we're still in autumn, remember, to October, to November. The sun's position on the earth is still getting more and more south. And let's stop on December 21st, right there. And now the sun is directly overhead for observers at this latitude on Earth, called the Tropic of Capricorn. All right? So now this is the longest day for observers in the southern hemisphere, and thus the shortest day for observers in the north. And over here we should see it's the exact opposite for what it was in June. The southern hemisphere is pointing towards the sun. The northern hemisphere is pointing away. So the angle of sunlight down here is closer to overhead. All right, I want to say it's steeper, but that you could be confused by that. It's closer to being overhead for observers in the southern. For observers in the northern, that's what this shows here. This is closer to the horizon. It's lower in the sky. And this is the first day of winter. It's the shortest day. The sun rises and stays pretty low in the sky. Oh, yeah, let's take a look at the sunbeam spread. Now, look how much that spread or that shape has stretched out and elongated, right? It's much, well, more oval, and the intensity is less. It's less bright. And so, again, this is for observers in Fresno. That means that it's cooler. It's not as hot. And this simply comes from the angle of the sunlight. It's much steeper in the winter, or what we know as in December, than it is in June. And so what we know as the seasons are completely inverted for observers in the southern hemisphere, right? In Fresno, we know December as winter, but it's their summer. Let's say 3 months later in March, we know it as spring, but in the southern hemisphere, it's their autumn. 3 months after that, in June, in the northern hemisphere, it's our summer, southern hemisphere's winter. And lastly, in September, or rather in our autumn, it's the southern hemisphere's spring. And so these seasons only occur because of the angle of the incoming sunlight. That's it.